Hello, everyone. This is the lecture for section 7.5, solving trig equations. Okay, so up to this point in chapter 5, we've covered how to do identities, and then using all of the identities on that yellow page that I handed out. Okay, there's one last thing to cover for section 7.5 or chapter 7 altogether. And that is how to solve trig equations. We haven't set trig equations equal to something else to find out their values, okay? At this point in the class, right, make sure that whenever you look at anything that has trig stuff on it, okay, that you have that yellow sheet in front of you, okay? It's going to save you so much time in having to look stuff up, okay? Okay. What I want to do in this section is I'm going to start out easy and then go, take it, a couple steps harder and harder as we go down, okay? One of the things that I'm not going to cover here, right, is using the inverse trig functions. You are more than welcome to use those to find solutions to trig equations, okay? The ones I'm concentrating on here deal with the unit circle just so that we can get a little bit more of a handle of what the heck we're looking at, okay? Okay, so that's really it. You are more than welcome to use inverse trig stuff if needed. Okay, so let's go ahead and jump in real quick. Okay, let's do these two, and I'm going to have this unit circle that's right here. If it ever, come on, this is supposed to be something I'm supposed to be able to click. Let's see, there it is. I'm going to have this unit circle that I'm just going to be dragging around everywhere so that you guys see what the heck I'm trying to do, okay? All right, so this first one, okay? I want to solve that out, okay? When is cosine theta minus 1/2 equal to 0? It's actually much simpler than it looks, right? So I want my cosine theta by itself, right? And to do that, right, I can grab that 1/2, that minus 1/2, and move it over. And you move it over exactly how you think you would. Plus 1/2 on this side, plus 1/2 on that side. So you get cosine of theta equals to 1/2. This is our magic little thing that we're going to be using. Okay? We're going to go ahead and look at our unit circle and see where cosine is equal to 1/2. Okay? The cosine is the x portion of our coordinates, right? So here's one and here's the other. So my two angles are those two. So then that means theta, my angle theta, has got to be equal to pi over 3 and 5 pi over 3, okay? Now, these are two of the angles that will do it, right? But if you remember, right, so this angle and this angle will do it. Both of those have cosine equal to 1/2, right? But if you remember, right, anything coterminal to this also works. So I can spin another 360 and land here. That one also counts. Another 360 around. That one also counts. Another 360 around this one, right? That one also counts. So 3 spins, 1, 2, 3 spins around pi over 3, all of those count, okay? So then that means my answer, I have to amend it a little bit so I can capture all of those. And the way we do that is plus 2 pi times k. Okay, and then we say k is any number. Bam. This is our complete answer right here, okay? So notice how this one doesn't say when I have to stop. Does that make sense? It's talking about all my angles, all the angles that make this right here, true, okay? And that is all of these, okay? A little bit later in this section, what I'm going to show you all is that sometimes it might restrict, okay? Okay, so we've got this one answered. Let's move on to the next one. Uh-oh, not what I wanted. Let's move you down here. There we go. Erase that. All right, next one, right? Sine of t is equal to negative a half, right? We're going to look over on our unit circle. Where is sine of t equal to negative a half? The sine portion of every coordinate, right, is the y portion. So where is the y coordinate equal to negative a half? One's right here. The other's right here. So I'm looking at these 2 points right here. Okay. So, and that means my two answers are going to be 7 pi over 6. Whoops, 7 pi over 6 over 6. Come on. And 11 pi over 6. Okay. And just like before, right? Any multiple rotations around the unit circle also produces an answer. So I have to do plus 2 pi k plus 2 pi k. We are done. Boom. Okay. All right. So what comes up next are some quick checks. Try these out on your own. We'll try them out in class. Okay. What I want to move on to now is things that have multiple powers instead of just linear powers. So what we just did was linear powers, when the powers of the sine are just to the power 1, right? When the powers of cosine are to the power 1. Okay. Now I'm increasing. You guys see this? See how this is now sine squared, right? You do the same exact thing. You're just adding one more move. You're adding a square root. That's it. Okay, so I still want sine theta by itself. Okay, let me rewrite it here too. Sine squared theta minus 1 equals 0. Okay, I still want that sine of 2 theta. Or sorry, the sine of theta by itself. So I'm going to get that, right? So I'm going to do plus 1, 2 sine squared theta is equal to 1. Divide by 2, divide by 2. Sine squared of theta is equal to 1/2. And this point, I get to take my square root of both sides. So then sine of theta is equal to plus or minus. So when you take the square root, it's going to be plus or minus whatever that thing is, right? The square root of 1/2. And if you guys remember, this is the same thing as plus or minus the square root of 2 over 2. So this is the thing that we're solving for now. Okay, I'm going to go back up here and grab my unit circle that I forgot. I'm going to grab it and drag it down. It's not moving as fast as I want, so I'm going to rush the stuff. There we go. I'm going to make it a little bigger so that everybody can see. Okay, so we're now down to this, right? We need to find when sine of theta is either positive root 2 over 2 or negative root 2 over 2, okay? Sine is the y portion, right? And when it's negative, positive or negative root 2 over 2, there's 4 of them. 1, 2, 3, 4. So here are my 4 angles. Okay, so this one has 4 answers. Okay, theta is equal to pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay, now, this is one of the things that I wanted to point out to everybody. I want everybody to direct your eyes to this. You see where it says from 0 to 2 pi? That means, right, I'm solving my equation on 0 to 2 pi. That means within one rotation of the unit circle, how many answers do I have, right? In this case, I only have 4. 1, 2, 3, 4. Okay, since the problem itself is directing me to restrict my answers to just one rotation around the unit circle, I only have 4 answers. If this We're not here. If I just said solve the equation on, just solve the equation, right? Solve that, then I would have to do the plus 2 pi k on the end of every one. So I'd have multiple answers and I'd have to capture each one, okay? So because this one has this thing on it, I'm done. This is all we need. This right here is all we need. Bam. Okay? So keep an eye on that, okay? More quick checks, blah, 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 blah. We'll try these out in class, okay? Okay, now gets to the fun stuff, okay? These are solving trigonometric identities, or solving equations using trigonometric identities, okay? The ones from before, we were able to solve out just by using sort of simple arithmetic, right? Some of them, sometimes, right, you will need some of the trig identities on your yellow page, okay, to figure them out, okay? These are a handful that sort of illustrate that pretty well, okay? So for example, let's go ahead and try and solve this one, okay? So it looks like we have a mixes of sines and cosines sitting around here on this equation, right? And doesn't seem like there's going to be a way for us to figure this out at all, right? This is where the trig identities come in, okay? So in particular, what I'm going to be using is this, right? So sine squared plus cosine, sine squared theta, right? Plus cosine squared theta. We know that that's equal to 1, right? Okay. I can also rewrite this, right, as sine squared theta is equal to 1 minus cosine squared theta. Got it? Okay. That's what we're going to use to substitute that. Okay, so then now our equation becomes this. 1 minus cosine squared theta is equal to 2 cosine theta, okay, plus 2. Okay, it looks messier now, but believe me, it's actually nicer, okay? So here's how I'm going to make it look nice, okay? I'm going to go ahead and grab everything and move it all to one side. In particular, I'm going to grab this end and move it over here, okay? And you do it the exact way you think you do it, right? So minus 2 cosine theta, minus 2. Minus 2 cosine theta, minus 2. What I get left with now is this. I'm going to start putting stuff in the order that it's supposed to go in, right? Minus cosine squared theta, okay? Minus 2 cosine theta, okay? Minus 1 is equal to 0. Okay, hopefully I haven't lost anybody yet, okay? What I can do here now, notice that everything has a negative in front of it, so minus, I can pull out the minus 1, and I get left with this. Cosine squared theta minus plus 2 cosine theta plus 1 is equal to 0. Okay, this doesn't look like it's made any progress, right? But I'm going to put this over here, okay? I'm going to go ahead and change everything. I'm going to change all the cosines into one particular variable, okay? I'm going to say it's going to be x squared plus 2x plus 1, okay? It's the same equation. The only difference is just that my x's, whoops, let me do it in a different color. My x's now, right, are the cosine thetas. Now, what I want you guys to look at is this. This is equivalent to x plus 1 squared. So that means our thing minus so basically all of this turned into this. Now it gets a little easier, right? Because we can't have all of this being equal to 0, right? And all of this being squared, right? Unless the thing inside the parentheses is actually 0. So then this tells me, I'm going to go ahead and carry this up here, that cosine of theta plus 1 has got to be equal to 0. Okay? So I'm going to do it again. We're getting closer. I'm going to grab my unit circle. I'm going to drag it down real fast. At least I'm going to try to. I'm going to put it right there. Bam. Okay. So we know now cosine of theta has got to be equal to negative 1. Minus 1, that's the move, right? All right. Now we get to look at our unit circle, right? When is cosine equal to negative 1? Cosine is the x portions of everything, right? So when is the x equal to negative 1? Bam. This is the only one. So then that means theta has got to be equal to pi. We are done. Okay? And notice I don't have to list anymore because this one has the magical on 0 to 2 pi. I'm only looking for answers within one spin of my unit circle. We are done. Okay? Whew, we're getting there. Okay, let's move this unit circle down some more. Actually, let's make it smaller because I'm going to need the space for this one. Oh, there we go. Okay, next one. Use the difference formulas to solve this thing. This thing looks atrocious, like absolutely nasty. If you didn't know that it looked like one of the trig identities that's on your yellow page, right? In particular, if you look at the difference formulas, okay, you can see that we have on this side, right, we have a cosine cosine plus sine sine, right? Go look at your unit, go look at your yellow page with the trig identities, right? You're going to realize this right here, that is, I'm going to write it down actually. Cosine alpha cosine beta plus sine alpha sine beta has got to be equal to cosine of alpha minus beta. And actually me, just so that I can conserve space, this is the same thing as cosine of alpha minus beta. This is the trig equation that we're going to need. This is the trig identity that we're going to need. Okay, so if you look at this, right, if you look at this problem that we have right here, we have the the left-hand side of our trig identity. So we can turn it into the right. We can turn it into the cosine of alpha minus beta. So then all of this gets to reduce down to cosine of x minus 2x is equal to root 3 over 2. You see how simple that was now? So then this tells me cosine of x is equal to, cosine of minus x is equal to root 3 over 2. Okay, now one more thing, okay? You guys see this? Cosine is an even function, so that means that negative inside don't matter. This is also on your yellow page, okay? So we are actually solving this. Where is cosine equal to positive root 3 over 2, right? The cosine is the x portion of our unit circle. So where is the x portion equal to positive root 3 over 2? We're going to move over here. Let's see. Bam, bam. Those are my 2 points right there. Okay, so, and again, this one has my magical little statement here, right? I only need answers within the first spin of the unit circle. X is equal to pi over 6, so 6, comma, 11 pi over 6. We are done. All right. We're getting there. We are getting there. Move this one down a little bit. Boom. Okay. Solve the equation exactly using the double angle formulas. This one's requiring a double angle formula. So in particular, we're going to need that for this left-hand side. Okay. Cosine has multiple of them, right? Choose the one that best suits the need that you want. Okay. So and in this case, right, hopefully you guys see that this is cosine of 2 theta, and then the other side has more cosine in it, right? So the odds are that I'm going to want to choose the one that's got the same stuff. Okay, I'm going to try to change the cosine of 2 theta into more cosine thetas, basically. Okay, in particular, this is the one that I'm going to use. I'm going to write it over here. Cosine of 2 theta is equal to 2 cosine squared theta minus 1. This is one of the double angle identities on your yellow page again. Okay, so then this reduces down to now, right, 2 cosine squared theta minus 1, right, is equal to cosine theta. Okay, now the gameplay is the same as before. I want everything on one side. Okay, 2 cosine squared theta minus cosine of theta minus 1 is equal to 0. Okay? Okay. I'm going to do a little bit more. Hopefully it doesn't look like voodoo math, but it sort of is. I can see how it is. I'm going to do this again. I'm going to do 2x squared minus x minus 1. Okay? I changed all the cosines into x's. Whatever was squared still remains squared. Okay? I want everybody to sort of verify this. Okay? This is equal to 2x plus 1, x minus 1. Okay? So if you do your foiling, if you foil stuff out, okay? If you do your first, outer, inner, last on this business right here, right? You get that it's equal to that thing right there in that multiplication that's right there, right below. That means this is going to be now 2 cosine theta plus 1 cosine theta minus 1 equal 0. Okay. Now we can treat this like we did before, right? 2 cosine of theta plus 1 is equal to 0, or cosine of theta minus 1 is equal to 0. Those are our two options, okay? Okay. This one, if you solve out for cosine, you get this. Cosine of theta is equal to, whoops, let me put the parentheses at the end. There we go. Cosine of theta is equal to negative 1/2, or cosine of theta is equal to 1. Okay, so now we need to solve two things. We need to get solutions for this one and this one. Let me actually color it a separate color. I'm going to color it purple. Okay. Hopefully you guys see. Let's start first with this one. Okay. When is cosine of theta equal to negative 1/2? Cosine is the x, so there should be a handful of answers. In particular, there should be two. There's going to be 2 pi over 3, if you look at the coordinate there, right? And then 4 pi over 3, if you look at the coordinate there. Okay, so theta is equal to 2 pi over 3, and actually I'm going to do this because I kind of want to, got a point to make here. 2 pi over 3 and 4 pi over 3. Okay, now, if you look at the statement of the problem, it does not limit me to one spin of the unit circle. So I got to give all my answers, right? Does that make sense? So I have to do this. For both of these, plus 2 pi k plus 2 pi k. Okay? These are the answers from the pink highlighted portion that we just looked at below. Okay? Hopefully you guys see that. Okay. Next one. When is cosine of theta equal to 1? There's only one angle that does that, thankfully. That one. So then that means my answers here are theta is equal to 0 degrees, right? Or 0 radians, plus 2 pi k. Remember, I have to capture every single spin of the unit circle because that's what it says up top. Okay? This is my answer for the purple ones. Okay? The collection of all three of these are the answers to this problem in particular. This is the first time I'm going to be squaring off an answer in green because I can't highlight without losing the colors. That's it. Okay. This one actually has multiple answers, right, that come from solving two equations. And if you do both of the equations, right, you get three separate answers. Okay. That now we have to take into account when we go around the unit circle multiple times because it doesn't restrict us to one spin of the unit circle. Boom. Good Lord. This is some good math today. This is some good math. Okay. Drink that one up. Okay. Last one that I got to do for today for this section, okay, is when you have multiple things. When you have multiple things inside the parentheses. So let me grab this unit circle. I'm going to drag this down real quick. There we go. Okay. So for example, this one. You guys see how I have a 2x inside, right? So you're probably thinking to yourself, how the hell do we do this, right? We know when it's x. What happens if it's 2x or 3x or x over 2 or theta over 5? You know, things like that. What do we do then, right? Okay. It's no different from solving the ones that we were just doing, okay? Except that after we find our angles, right, we now have to do a little bit of math after that. So for example, what I'm going to do is this. You can completely do this as well when you're doing these on your own, right? I'm just going to put a big, huge, fat dot, okay? We are looking for angles such that the cosine of those angles is 1/2, okay? In our case, two of them do it. Yeah, let me do this. Pi over 3 and 5 pi over 3. Those are the two angles where the cosine is equal to 1/2, right? So then that means my big, huge dot, right, has got to be equal to pi over 3 or 5 pi over 3, okay? Now, look at this. You guys ready? That thing was covering up 2x, so then that means this is going to be 2x. We at least found our angles from the unit circle, right? Okay. Now, how do we still, I mean, we have two angles, right? But there's still a 2 in the way. What the heck do we do with that? Okay. Just how you think, right? We need to divide away that 2. We need the x by itself, so we need to divide away the 2, right? This is something that I haven't done in class, right? Because of, just to keep you guys from getting confused, right? If I want to divide, I'm going to do this in pink. If I want to divide away by 2, I need to divide by 2 over here, right? And that's exactly what we're going to do, but I'm going to do it, I'm going to sort of state it a secondary way, another way. That is equivalent to multiplying by 1/2. Okay, since I'm multiplying by 1/2 on everything on this side, that'll get rid of, that cancels, basically that cancels that, right? But then I have to do the exact same thing over here. So I'm going to multiply by 1/2 here, times 1/2. Okay, now on each one of these, we have a multiplication of fractions. And then my x stays by itself, right? Pi over 3 times 1/2, that is going to be pi over 6. And then 5 pi over 3 times 1/2, that's going to be 5 pi over 6. Now we are done. Boom. Okay. I think up to this point in the class, we've played around with sines and cosines and the tricky stuff pretty nicely so we can get comfortable with this, right? This is nothing you haven't seen before, right? It is something that I haven't made you practice on before, okay? Like I said, just have your yellow sheet open and in front of you when you're doing these kind of problems, even the ones online, okay? I believe after that is lecture questions, okay? If you have any questions on any of the stuff that I just covered, ask me during our quick check time or come downstairs to the tutoring center. I'll be there, okay? Besides that, happy studying.